Yes, now we will discuss about DMVPN working. Okay, so for that we required a new diagram. Please have patience. Okay, for that we will not require thick pen. We will require here thin pen. Okay, so assume R1 that is connected with ISP and ISP is connected with R2 and R3. Okay, R1 has lane here A, R2 has lane here B, and R3 has lane C. Now we have to type the public IP address. Yes, first IP address belongs to ISP 102.1.100 and 103.1.1.100. Done. So this is our small network. You can add here new branches also, but the working will be same here. Okay, now first here we have to define also tunnel 0. For example, IP 192.168.1.1. Its IP tunnel 0 192.168.1.2, and here tunnel 0 192.168.1.3. Yes, we have to do these things here. First we have to configure routing properly, means they should be connected to internet. Now we have to define here, this is not 2, this is here tunnel 0. Okay, so what happened when the client will boot up? For example, we are talking about the point of view of, yes, R2. Okay, when R2 will boot up, it will register. Okay, when R2 will boot up, it will register itself with the server. Yes, when R2 will boot up, first point, when R2 will boot up, it will register itself with the server, and it will register two things. First, tunnel IP, second, public IP. Okay, so it will register to the server, and server will maintain a database. Yes, who is coming here? Yes, who is coming? For example, R2 is coming. Okay, and what it is bringing? Yes, here we can say tunnel IP and public IP. Yes, we can add here two things. Okay, please have patience. Tunnel IP and public IP. Okay, so what is the tunnel IP of R2? Yes, 192.168.1.2 and public IP 102.1.1.100. Same procedure, R3 will also register itself with the server and it will register same information. Yes, 3 will also register tunnel IP. Yes, its tunnel IP is 192.168.1.3 and yes, public IP is 103.1.100. Done. When they will register, all the clients will register their all tunnel IPs and public IP with the server. When they will register, yes, tunnel will up and they will also exchange their network information. For example, what? B and C. So here we can use routing protocol. So routing protocol are responsible to exchanging the routes. So what will happen here? Yes, when routes will be exchanged, then all routing protocol, for example, we are using here, you can choose here any routing protocol. So R1 will advertise all the networks to each other. Okay, B, okay, R1 will say, yes, if you want to access network A, yes, network A next hop is, yes, which one? 1.1, 1.1. And if you want to access network C, yes, that's next hop is 1.3. Okay, same, R1 will tell to R3 also, if you want to access network, yes, A, then you can directly forward the packet to 1.1. Here I am typing in short. 1.1 means here we can assume, okay, A, if you want to access network A, then your next hop, the good next hop is 1.1. If you want to access network C, then you have to forward the packet to 1.3. Same, if you want to access network A, your next hop for this network is 1.1, and if you want to access network B, your next hop for this network is 1.2. Yes, so this routes will be exchanged via, yes, hub will exchange the routes of each client to each other. Okay, now assume what is happening. For example, this is the routing table of the router. Same you can see here. Okay, now assume this C want to communicate B. So it will generate a packet. So source IP will be here C and destination IP will be here B. So this packet will be generated by lane. This packet will be generated by lane and this packet will be forwarded to the gateway. Now gateway will check what is the destination. Yes, destination is B. Then it will check its routing table. Yes, B network is learned from the 1.2. Then it will check what is the public IP of 1.2, so it has no information. So what I told you here, yes, DMVPN limitation, yes, first client will initiate a request. Now what will do, yes, this client will send two packets. This client will send two things to the server. First it will send, yes, initial packet. Second, it will generate NHRP request. In NHRP request, it will ask that what is the IP NBMA IP of 192.168.1.3. Yes, not 1.3 here. B network is learned from 1.2. So it will ask for NBMA IP of 1.2. So these two requests will go to the server. Okay, first what the server will do? Yes, the initial packet. The initial packet, okay, how many things forwarded by these R3? Yes, two. First is here initial packet. First assume this is initial packet and this is our NHRP query. So server will forward initial packet to the actual destination. And who is actual destination? Yes, actual destination is here. Yes, initial packet, again I am saying initial packet will forward it to the R2. Yes, that is the actual destination for the destination. What is the destination? B. Okay, then R1 will see B is learned from 102.1.1.100. Yes, packet will be forwarded to the P. Okay, now next thing is NHRP request. Then server will check. Okay, what is asking? Yes, the client is asking about the public IP of 1.2. Okay, 1.2 public IP is here. Yes, this one. So it will give it a reply. In reply, it will say yes, 192.168.1.2 has public IP 102.1.100. So this information will be sent from R1 to R3. Okay, now it will come to know, yes, 192.168.1.2 has public IP 102.1.100. Done. Okay, now R3 is able to learn that what is the public IP of client, no problem. So it has the IP. Now think what happened when the packet went to the, yes, R2. Okay, again I am repeating. When the connection was initiated from the R3, R3 will initiate two packet, initial packet and NHRP request. Both will be forwarded to the R1, means hub. Initial packet will forward to the destination, then R1 will give the reply of the NHRP query. Now NHRP reply contains the NBMA address of the peer. Yes, peer IP tunnel IP is 1.2 and its public IP in the database 102.1.100. Now R3 is capable to learn. Okay, now when the initial packet will forward it to the destination, yes, packet went to the B lane. Okay, when the reverse packet will come, it will generate a packet. Yes, source IP will be here B and destination IP will be here C. Yes, this packet will come at the R2. Okay, what will happen? R2 will check what is the destination here. Yes, destination is C and what is the tunnel IP 1.3. So just like R3, it will send a request. Yes, what is the public IP, it will send a same. R2 will send a request to R1 that what is the public IP of 1.3. Then server will check. Okay, request will be sent from R2 to R1. Yes, request arrive here. Okay, it will check. Okay, the client want to know the public IP of 1.3. What is the public IP of 1.3? Yes, 103.1.1.100. So R2 will give reply to the R1 will give the reply to the R2, and yes, it will give yes 103.1.1.100 is the public IP of 1.3. Now both R2 and R3 have the public IP of each other. Then what will they will do? Yes, they will perform phase 1. After phase 1, they will perform phase 2. When phase 2 will complete, then they will communicate directly to each other. When all the phases will complete, yes, they will perform phase 1, then they will perform phase 2. When all the communication or all phases will be complete, then all the packets will go directly via dynamic tunnel. Okay, now there is no need to communicate via hub. So this is the working of DMVPN. Okay, again I am going through, I am giving you a brief of DMVPN working. First of all, okay, as you can see the network is so congested, or diagram is so congested here. Okay, then again we will try. Okay, so what happened in DMVPN? If we want to know the DMVPN working, first if we have three routers here, R1, this is our R1, and this is our R2 and R3. Okay, now R1 we are treating as hub here, and 2 and 3 we are treating as spokes. Yes, spoke. Okay, when client means spokes will boot up, it will register itself with the server. Yes, it will register its two information, first tunnel IP and second public IP. Using this procedure, all the client will register themselves with the server. Okay, no problem. When one client lane, for example, R3 lane want to communicate with R1 lane, that will generate a packet. Yes, source will be its lane, destination will be yes PRL and spoke lane. Then the packet will come at the gateway will check what is the destination. Yes, destination is B. It will check its routing table. Okay, it will check yes that is learned from the tunnel, but I don't have the public IP information, so it will initiate two things. First, it will send initial packet, as you can see. Second thing, it will generate NHRP request. In NHRP request, it want to know yes the peer IP, we can say tunnel IP, public IP. So all the request, it will generate two things. First, initial packet, and then second is NHR request. All the packets will go to hub. Initial packets will be redirected to the actual destination. Now hub will give the reply of NHRP query. Yes, client wants to know the public IP of 1.2. Okay, what is the public IP of 1.2? 102.1.1.100. So this reply will be offered to the client. Then client will maintain okay 1.2 has public IP 102.1.1.100. Now what happened when the initial packet will be received by R2, it will forward it to the destination. When the reverse packet will come, okay, you can see source will be here B. Yes, source is B. Destination will be C. Yes, C. Then this packet will come to the R2. Okay, when R2 will packet will come at R2, R2 will check its routing table. Yes, C is learned from 1.3, but I don't have the information about public IP. So again, it will send a request to the server with the tunnel IP 1.3. Then server will check its database. There 1.3 has public IP 103.1.1.100, and it will forward it to the peer. Okay, now it will maintain 1.3 has public IP 103.1.1.100. Now both peers have public IP of each other. They will perform here. Yes, they will perform phase 1 and phase 2. Then when phase 1 and phase 2 will complete, yes, they will create a dynamic tunnel. Now they can communicate to each other. Yes, so this is our working of DMVPN. Now